Hello. Now we are going to continue our work with revising angles and triangles. So for right angle triangles, one of the most important formulas that we know is the theorem of Pythagoras. And this is in our formula tables, and it is the side across from the right angle in a right angle triangle is called the hypotenuse. And if we square the length of the hypotenuse, the square of the longest side, it's equal to the square of the other two sides added together. The square on the hypotenuse is equal to the sum of the squares on the other two sides. And this is a very important tool anytime we see right angle triangles. Another thing we know about triangles is how to show that they are equal in size. So the geometry name for equal things is congruent. It just means they're the same size and shape, which in other areas of maths we'd often say equal for the same general notion. And we can be asked to show how we know that things are the same, how we know that triangles are congruent to each other. And there's a few standard ways of doing that. The first is if we can show that all of the sides are the same length, then the two triangles have to be equal to each other. So the sides in the corresponding places, in the equivalent places in both triangles, if they're all equal to each other, then the triangles have to be identical. They have to be equal or congruent. Another way that we can show this is by side angle side. If we have a side and another side and the angle in between them, so reading across we'd have side, angle, side, then that would mean if they're equal in both triangles, then they must also be congruent. They must also be equal. We could have an angle at a corner, then the side, and then another angle. So two angles and the side in between would guarantee that we had two triangles being congruent as well. And finally, if we have a right angle triangle, we can have the right angle, the hypotenuse, which is the longest side across from the right angle, being equal, and then either of the other two sides being equal as well is enough to show congruence. Where these rules come from is constructions. So these are the different ways that you can construct triangles as well. If you knew all three sides, you could construct a triangle. If you knew a side length, an angle in between, and a side length, you could construct a triangle, and so on. So these rules mainly come from how would you construct, how would you draw a triangle accurately. If you had enough information to accurately draw a triangle for both triangles, then you'd be able to see if they were congruent, or if you had the same information for both to draw them, they'd be congruent. Now let's put this into practice. So how would I find my missing side here? I'm going to call it y. So how would I find my side length y? Well, I see that the shape I've been given is a right angle triangle. So I think about the tools I know for a right angle triangle, and one of the big ones is Pythagoras. So if I see that I'm looking for the sides of a right angle triangle, I'm immediately going to go to my log tables and write down the Pythagoras theorem. So h squared, the hypotenuse squared, is equal to the sum of the squares on the other two sides, a squared and b squared. Now a and b are interchangeable. It doesn't matter which one of the other sides we pick as a and b, but h matters a lot. It has to be the side across from the right angle. So now we have our formula written down. H is 10. That's the hypotenuse across from the right angle. So I'm going to say that h is 10. So I sub that in brackets. A, it doesn't matter whether I call that y or 6. Either of those two sides are interchangeable. I'm going to call A y. So I'm going to sub in y. And 6 is the remaining one I'm going to put in for B. And now I just solve my equation. 10 squared is 100. Y. We just put this into the calculator and simplify down. I want to get y by itself, so I'm going to subtract 36 from this side. So I'm just left with y squared. And I have to do the same thing to the other side, or else it wouldn't be equal anymore. If I make this smaller by 36 and don't change this, then it's not equal anymore. So I end up with 64 is equal to y squared. I have to take the square root in order to get rid of the square. Ordinarily, that would mean I'd have a plus or minus answer, but this is the length of the side of something, so I don't need to worry about the negative possible result. But we should always think when we take a square root, we could end up with a negative result. But here, it's a physical object. I'm not worried about negative numbers. So I end up with y being 8. Now, we can be asked about how to show congruence. So is the triangle symbol ABC, so I have my corners labeled A, B, C. The corners are called vertices, and we can see that word in the exam. So vertex means corner. And is the triangle ABC congruent, that's an equal sign with an extra line, to triangle DEF, DEF. So it's useful, even if they don't give us letters in the exam, to label the corners of our triangle so we can more easily talk about what sides we are trying to say are equal to each other or different to each other. Now, in this case, we have enough information to show congruence in two different ways. And that's just to give you an example of how this can work with different styles of information. So I can see that the side A to C is 24 units long, and the side D to E is 24 units long. And then if I come around the corner, that angle is 20, and the corresponding angle here is 20, and then the side afterwards is 19, and E to F is 19. So I have a side, an angle, and a side in that order gives me congruence. So I could say the length of AC, so I have my corners and I have my parallel lines or my big lines on either side to say the length of AC is equal to the length of DE. They're the same length, that's our length symbol. We'd use our distance formula sometimes for Earth when we see that. And they're both equal to 24, so they're equal to each other. And the angle A to C to B, from A to C to B, the angle at the corner is always going to be the one at the middle. So to label an angle, we say angle symbol, and we start and we walk in from A to C and then out again to B. So the angle we're talking about is in between, that's 20. And D to E to F is the same. They're both 20 degrees. So D to E to F, we're told that that's 20 degrees. And we're told B to C is 19, and the corresponding place, E to F, is also 19. So the length of B to C, or C to B, it doesn't make a difference which way around you write that, is equal to the length of E to F. We're told that they're both 19. So we could say that's enough information. That's side, angle, side, written or read across the shape for both of them. So that would be congruent by side, angle, side. So we'd be able to say that they're congruent that way. But we've also been given an extra piece of information. We have the angle ABC. Now we don't know the size of that angle, but we can see we have a dot in the same place. The corresponding angle has the dot there. So that would tell me that ABC is the same as the angle DFE. So I'd have angle, side of 19, and then another angle for both of my triangles. So that would be another way to show congruence. So that would be the job done, but we're going to do it a different way just to highlight our dot, meaning the angle is the same. We could say the angle A to B to C is equal to the angle D to F to E. That's our dot, and that's given to us. We're not told what number it is, but we're told in the diagram that that is the same. So we say it's given to us. Then we know what we've already written down. The side B to C is the same as the length of F to E. That's 19. And we know the angle B to C to A is the way I'm going to read it this time. It's the same as what we would have done here. So A to C to B and B to C to A is just a different way of reading it. Here I'm coming from here, so B to C to A. To A is the same as the angle F to E to D. We just walk into the corner and back out again in order to label our angle. That's 20 degrees. So we'd be able to say that they're congruent by A, S, A, because we know an angle, then the side, then another angle. So we know the side in between two angles in the corresponding places for both triangles, so we know that they are congruent. So that's two different ways you could show congruence based on the information given there, and we've practiced our very important tool for right angle triangles, which is Pythagoras' theorem. And that is what we need for now.